The Improbable Ape, A Journey Through the Astronomical Odds of Human Existence, by Rob Corley. Written and produced by Rob Corley. The center of everything. Here's the thing about discovering you live in a fine-tuned universe. It's humbling. And humans haven't always been good at humility when it comes to our place in the cosmos. For most of human history, we thought we were the center of everything, not metaphorically, literally. We built our understanding of the universe around the assumption that we were special, that everything revolved around us. The earth was the unmoving foundation of reality, and the heavens wheeled around us in perfect, eternal circles. It seemed obvious. Look up at the night sky and what do you see? The sun rises in the east, arcs across the heavens, and sets in the west. The moon follows its own stately dance. The stars wheel overhead in their ancient patterns, returning to the same positions night after night, season after season. Everything in the cosmos appears to revolve around us, and why shouldn't it? We're here, after all. We're conscious, thinking, observing. We're the ones asking the questions. Surely that makes us special. Surely that puts us at the center of things. It took centuries of scientific discovery to teach us otherwise, and each lesson was harder to swallow than the last. The comfortable delusion. Picture yourself as a medieval peasant, standing in a field at twilight, watching the stars emerge one by one in the darkening sky. The earth beneath your feet feels solid, immovable, eternal. The heavens above seem to turn like a great celestial sphere, carrying the sun, moon, and stars in their appointed courses around your world. This wasn't just a casual observation, it was a complete cosmological system, refined by the greatest minds of antiquity. Aristotle had argued that the earth must be at the center of the universe because heavy objects naturally fall toward the center, and what could be heavier than the earth itself? Ptolemy had worked out the mathematical details, creating an intricate model of nested spheres and epicycles that could predict the movements of the planets with remarkable accuracy. The geocentric model wasn't just scientifically respectable, it was psychologically comforting. It placed humanity at the center of creation, the focal point around which all of existence revolved. We weren't just observers of the cosmic drama, we were its main characters, the reason for the whole elaborate show. This worldview was more than astronomy. It was theology, philosophy, and psychology all rolled into one. The earth was the stage upon which the great drama of human salvation played out. Heaven was literally above us, hell literally below. The celestial spheres were the realm of perfection, while our world was the realm of change, decay, and redemption. It was a universe built for us, around us, about us, and it was completely wrong. The first crack in the crystal spheres. The revolution began quietly, with a Polish canon named Nicolaus Copernicus, who spent his nights observing the heavens from a tower in Frombork. Copernicus wasn't trying to overthrow the cosmic order, he was trying to fix it. The Ptolemaic system, for all its mathematical elegance, had grown increasingly unwieldy over the centuries. Astronomers had been forced to add epicycle upon epicycle to account for the observed motions of the planets, creating a cosmic Rube Goldberg machine of staggering complexity. Copernicus had a radical idea. What if the Earth wasn't the center of everything? What if it was just another planet, orbiting the Sun along with Mercury, Venus, Mars, Jupiter, and Saturn? The idea wasn't entirely new. The ancient Greek astronomer Aristarchus had proposed something similar 18 centuries earlier. But Copernicus worked out the mathematical details, showing how a heliocentric model could explain the observed motions of the planets more simply and elegantly than the geocentric system. When Copernicus finally published On the Revolutions of the Celestial Spheres in 1543, he knew he was lighting a fuse. In his dedication to Pope Paul III, he wrote that he had hesitated for years to publish his work, knowing it would seem almost contrary to common sense. He was right to be worried. The Copernican system didn't just move the Earth, it demoted humanity. We were no longer the center of creation, the focal point of divine attention. We were passengers on a spinning ball of rock, hurtling through space around an ordinary star. The comfortable, human-centered universe was beginning to crack. The telescope changes everything. For decades after Copernicus, the debate raged between the old and new world views. The geocentric system still had powerful defenders, and the heliocentric model had its own problems. If the Earth was really moving, why didn't we feel it? Why didn't objects fly off into space? Why didn't the stars show parallax as the Earth orbited the Sun? Then, in 1609, an Italian mathematician named Galileo Galilei heard rumors of a new invention from the Netherlands, a device that could make distant objects appear closer. Within months, Galileo had built his own telescope and turned it toward the heavens. What he saw changed everything. The moon, that perfect celestial sphere, was revealed to be a world of mountains and craters, as rough and imperfect as the Earth itself. The Milky Way, that faint band of light across the night sky, resolved into countless individual stars. Jupiter had 4 moons of its own, proving that not everything in the heavens revolved around the Earth. Venus showed phases like the moon, exactly as the Copernican model predicted. Most shocking of all, the Sun itself was imperfect. Through his telescope, Galileo could see dark spots moving across its surface, sunspots that proved the Sun was rotating, and that the celestial realm was subject to change, just like the terrestrial world. Galileo's telescopic observations provided the first direct evidence that the Copernican model was correct. But the implications went far beyond astronomy. If the Earth was just another planet, if the heavens were made of the same imperfect matter as our world, then what made humanity special? What made us the center of anything? The Catholic Church, recognizing the threat to its cosmological authority, forced Galileo to recant his support for the Copernican system. But the damage was done. The crystal spheres of medieval cosmology had been shattered, and humanity had taken its first step away from the center of the universe. The infinite cosmos. As telescopes improved and observations accumulated, the universe kept getting bigger and stranger. In the 18th century, William Herschel discovered that our solar system was embedded in a vast disk of stars, what we now call the Milky Way galaxy. But even this seemed to preserve some vestige of human specialness. Surely our galaxy was the entire universe, and surely we were near its center. Wrong again. In the early 20th century, Edwin Hubble used the new 100-inch telescope at Mount Wilson to study what astronomers called spiral nebulae, fuzzy patches of light scattered across the sky. By measuring the brightness of certain variable stars in these nebulae, Hubble proved that they were actually other galaxies, island universes millions of light years away. The universe wasn't just bigger than we had imagined, it was unimaginably vast. Our galaxy, which had seemed like the entire cosmos, was just one of billions scattered through space like islands in an infinite ocean. But Hubble's discoveries didn't stop there. By measuring the light from distant galaxies, he found that they were all moving away from us, and the farther away they were, the faster they were receding. The universe itself was expanding, carrying the galaxies apart like raisins in a rising loaf of bread. This discovery led to one of the most profound insights in the history of science. The universe had a beginning. If the galaxies were flying apart now, then in the past they must have been closer together. Wind the clock back far enough, and you reach a moment when all the matter and energy in the universe was compressed into an infinitesimally small point, the Big Bang. Suddenly, the universe had a history. It wasn't eternal and unchanging, as philosophers had assumed for millennia. It was dynamic, evolving, with a definite beginning and an uncertain future. And we were just temporary passengers on a small planet orbiting an ordinary star in an unremarkable galaxy, somewhere in the middle of this vast, expanding cosmos. The mediocrity principle. Each new discovery seemed to reinforce the same humbling lesson. We are not special. The Earth is not the center of the solar system. The solar system is not the center of the galaxy. The galaxy is not the center of the universe. In fact, the universe doesn't seem to have a center at all. It's expanding uniformly in all directions, so every point looks like the center from its own perspective. This pattern of cosmic demotion became so consistent that astronomers gave it a name, the Copernican principle, or the principle of mediocrity. It states that we should not assume we occupy a special or privileged position in the universe. Earth is a typical planet, the Sun is a typical star, the Milky Way is a typical galaxy. We are, in Carl Sagan's memorable phrase, living on a mote of dust suspended in a sunbeam. The Copernican principle became one of the guiding assumptions of modern science. When we study the universe, we assume that the laws of physics are the same everywhere, that the chemical elements behave the same way in distant galaxies as they do in our laboratories, that the fundamental constants of nature are truly constant across space and time. This assumption has been spectacularly successful. It's allowed us to understand the life cycles of stars, the formation of galaxies, the synthesis of elements in stellar cores. It's given us the Big Bang theory, the discovery of dark matter and dark energy, the detection of exoplanets and gravitational waves. But it's also created a paradox, because the more we learn about the universe, the more special our existence appears to be. The paradox of cosmic humility. Here's the irony. The same scientific revolution that dethroned humanity from the center of the universe has revealed just how extraordinary our existence really is. The Copernican principle taught us not to assume we're special, but the evidence suggests we might be special anyway. Consider what we've learned about the requirements for life. A planet needs to be in the habitable zone around its star, not too hot, not too cold. It needs a stable orbit, a protective magnetic field, a suitable atmosphere. The star itself needs to be the right type, not too big, not too small, not too variable. The galaxy needs to have the right chemical composition, the right level of stellar activity, the right structure. And as we saw in the previous chapter, the universe itself needs to have exactly the right physical laws and constants. Change any one of dozens of fundamental parameters by a tiny amount, and stars wouldn't form, planets wouldn't exist, chemistry wouldn't work, life would be impossible. The more we learn about these requirements, the more improbable our existence appears. We may not be at the center of the universe, but we seem to be the beneficiaries of an almost impossible series of cosmic coincidences. This creates a tension at the heart of modern cosmology. The Copernican principle tells us not to assume we're special, but the fine-tuning of the universe suggests we might be the product of extraordinarily special circumstances. How do we reconcile these two perspectives? The anthropic resolution. One answer is the anthropic principle, which we touched on in the previous chapter. The weak anthropic principle states that we observe the universe to have life-friendly properties, because if it didn't, we wouldn't be here to observe it. It's not that the universe was designed for us, it's that we could only have evolved in a universe that happened to have the right properties for life. This principle allows us to maintain our cosmic humility while acknowledging the apparent fine-tuning of the universe. We're not special in the sense of being the intended purpose of creation, but we are special in the sense of being the unlikely beneficiaries of a cosmic lottery with odds so long they approach the impossible. Think of it this way. Imagine a vast casino with trillions of slot machines, each representing a possible universe with different physical laws and constants. Most of these machines pay out nothing. They produce sterile universes incapable of supporting life. But a few machines, against all odds, hit the jackpot and produce universes where stars can form, planets can exist, and life can evolve. We're not playing the slot machines, we're the jackpot. We exist because we happen to be in one of the vanishingly rare universes that won the cosmic lottery. From our perspective, it might seem like the universe was designed for us, but that's just a selection effect. We couldn't have evolved in any of the losing universes, so of course we find ourselves in a winning one. This perspective, that we're simultaneously insignificant and extraordinary, represents a profound shift in human consciousness. For most of our history, we saw ourselves as the center of creation, the focal point of divine attention. The scientific revolution taught us that we're actually peripheral, marginal, cosmically unimportant. But now we're learning that we might be something even more remarkable. We might be the universe's way of understanding itself. Think about what you represent. You are a collection of atoms forged in the hearts of dying stars, organized by billions of years of evolution into a pattern complex enough to contemplate its own existence. You are matter that has become conscious, stardust that has learned to wonder about the stars. In you, the universe has developed the capacity for self-reflection. Through your eyes, the cosmos can observe its own vastness. Through your mind, it can ponder its own mysteries. Through your emotions, it can experience wonder at its own beauty. This doesn't make you the center of the universe in the old geocentric sense. You're not the focal point around which everything else revolves. But you might be something even more special. You might be the point at which the universe becomes aware of itself. The philosopher Thomas Nagel wrote about the view from nowhere, the attempt to understand the universe from an objective, detached perspective that transcends our particular human viewpoint. But perhaps that's backwards. Perhaps the most remarkable thing about the universe is not that it can be viewed from nowhere, but that it can be viewed from somewhere, from the specific, subjective, conscious perspective of beings like us. The cosmic perspective. So where does this leave us? We've traveled a long way from the medieval peasant standing in his field, confident that the Earth was the center of creation. We've learned that we live on a small planet orbiting an ordinary star in an unremarkable galaxy, somewhere in the middle of a vast, expanding universe that began 13.8 billion years ago and will continue evolving for trillions of years to come. We've learned that we're not the center of anything in the spatial sense, but we might be central in a different way, as the universe's way of knowing itself, of experiencing wonder, of asking why anything exists at all. This is the cosmic perspective that science has given us. We are simultaneously insignificant and extraordinary, peripheral and central, ordinary and miraculous. We are the products of chance and necessity, of cosmic accidents and physical laws, of stellar death and biological evolution. We are not the center of the universe, but we are something perhaps even more remarkable. We are the universe becoming conscious of itself. And that consciousness, that capacity for wonder and understanding, didn't emerge in just any universe. It emerged in this one, a cosmos so exquisitely fine-tuned for complexity and life that it makes our personal existence seem almost reasonable by comparison. But even in this fine-tuned universe, our planet needed additional layers of protection to become a cradle for life. The cosmic constants might be set perfectly, but that's just the beginning of the story. Earth needed shields and stabilizers, guardians and guides, to transform the raw potential of a life-friendly universe into the actual reality of a living world. That's where our story goes next, to the specific local miracles that made our planet not just habitable, but a paradise for life in all its magnificent diversity.